From building models manually to generating beautiful reports with Python libraries with no code and now even using large language models, data science has come a long way. But there's one thing that hasn't changed. EDA, Exploratory Data Analysis, still remains the most important part of any project. In this video, we'll take you through the NYC taxi trip duration dataset and we'll explore a roadmap that makes EDA not just effective but exciting. First, we'll do some traditional analysis, univariate, bivariate and multivariate using libraries like Matplotlib, Seaborn, Plotly to get a real sense of what the data is telling us. Then, we will move into feature engineering, creating new variables that could actually improve model performance. After that, we will show you how to use Sweetviz for automated profiling, which gives you instant interactive reports in seconds. And finally, we will bring in some AI magic using PandasAI with OpenAI so we can literally ask our data question in plain English and get meaningful answers back. By the end of this, you will see how EDA has evolved and how you can make it faster, smarter and lot more fun. So, let's get into it.
We all know that how important it is to have data which is available for building amazing machine learning models and whatnot, right? But if you don't know what that data holds, what is the story behind that data, what that data is trying to tell us, then you're not able to connect to the actual problem that you're solving. So to help us do that, to help us achieve that, today in our special class, we're going to be talking about three amazing ways of exploring the data and generating beautiful insights out of it. So in this section, we're going to be talking about how traditionally people used to, take advantage of packages like Seaborn, Matplotlib, Plotly for interactive charts and do various kinds of data analysis. And then using auto EDA kind of packages like Sweetviz, which just takes your data and generates an amazing dashboard things for you, state of the art out of the box. And then how can we leave the world of LLM behind, right? So how can using a package called Pandas AI and using OpenAI with simple prompts, you can explore your data in a beautiful way. So I'm Jen. I'm going to be walking you down this entire process of three amazing ways of doing EDA in our today's special class on EDA roadmap. So with that, let's dive in.
Just a quick note, Analytics Vidhya has 100 plus free courses from beginner to advanced on topics like machine learning, generative AI, agents, etc. Complete with certification. Click the I button to explore now.
As you can see that I'm using Google Colab to do all these data operations. This is to make sure that anyone who is doing all these EDAs and visualization for the first time, you don't have to worry about the extensive amount of work that requires to configure Python and set up the environment to run these codes, right? In the longer run, that's going to be really helpful. But for the beginners and for people who are quickly looking out to do some quick data analysis, Google Colab provides you an amazing opportunity. For example, I'm using my own personal Google Colab window here, which is free of cost. Plus, it allows me to do all these visualizations that I talked about without any extra cost, right? So the prerequisites for this is a data set. I'm using New York taxi trip duration data set. We'll talk about this data set more in a while. This data set I'm using as an anchor to build the entire storyline. You can use any of your data set, anything that you are working on, something that you can relate with it, things which will be more applicable for your domain. You can use that, right? So I'll tell you about those things also, how you can leverage those things. Awesome. Perfect. All right. So all you need is a simple CSV file for this workshop and you are good to go. Now Google Colab comes with an extensive power. So I'm using this window free resource, which is giving me around 12.7 GB of RAM and 107 GB of memory space, right? And in that package, I'm able to run all these codes. Now, Google Colab comes pre-bundled with a lot of amazing packages. But sometimes what happens is those packages might not be there because either they got updated or they got changed. So I'm using three different notebooks here to work on amazing three different projects. So what I'm trying to do is I'm trying to tell you that how I am able to import all these packages in my notebook. In case you don't have a package, all you have to do is click on type pip install and the package name. For example, in my first case study today, right, we're going to be doing three things: the traditional EDA, the automated EDA, and using AI. For the traditional EDA, I need some basic packages, namely Pandas, NumPy, Matplotlib, Seaborn, and Plotly. Now, Pandas is used for doing data frame related tasks, to read your file, to do any kind of feature engineering on your file, to structure it, restructure it, right? To all those activities that are related to your file, we use packages like Pandas. NumPy is for all your numerical, statistical, and calculations. Any kind of mathematical operations are required, we will be routing towards the package of NumPy. Matplotlib, as you can see on my screen, is used for visualization. It's a very powerful tool that allows us to work on various kinds of charts and to help us visualize our data, right? And if you are interested, it's actually very good. You should be curious about it. If you go to your browsing window and search for Matplotlib, it gives you a beautiful documentation in terms of what all it can do, right? Using a package state of the box is a good traditional practice that we all do, but knowing about these packages a little bit is going to be really helpful for the down the line, right? So Matplotlib is one such package which allows you to build simple charts that could be really helpful for the business. Then the advanced form of Matplotlib, that is called Seaborn. Now Seaborn was built on top of Matplotlib. So definitely all the things which Matplotlib can do, Seaborn can also do with little bit of more, advancement. So Matplotlib is a lighter version of visualization package, and on the contrary, Seaborn is of a more of an advanced charts that requires little bit of more, like visual elements and like fancy visuals and aids that could be really helpful for your presentations or your report also. And other than Seaborn, we are using a package called Plotly. And I hope a lot of you might already know that the difference between Matplotlib, Seaborn, and Plotly is that Plotly focuses on building charts that you can interact with. Interact with means it's a wonderful package. If you look at this documentation for Plotly, it helps you build charts which can be interactive in nature. But that means when I hover over a chart, it gives me information about it. It gives you way more complex charts in a more user-friendly way, right? As you can see on these recordings, the user is navigating through those data points and a legend or a tooltip comes on top of it, which is telling what information is holding off for that particular cell. This is something which is missing in the Matplotlib and the Seaborn packages. However, for Plotly, this is an amazing thing. You can make charts that talk for themselves, right? So imagine you are in a presentation and you're hovering over the entire statistics, right? A world map or a bar chart or a histogram or a line chart or a trend chart. And the moment you want to focus on a particular data point, on a particular date or a country, and you hover over there and a small box pops up, which gives you extra information. That's going to be really helpful for you, right? Isn't it? So that's the objective. And that's why we are stressing on building products that are more interactive and user friendly. That means in our today's session, we're going to be focusing on Matplotlib, Seaborn, and Plotly. But as you know that I have already installed these packages. Collab should have all these packages out of the box. You don't need to run these commands. The only reason I have written this command, in case in future if you are using a package and if it is not there, just do !pip install and package names and it will install it there. Then I am trying to connect to my Google Drive because this CSV file is present in my Google Drive, right? So for that, what I'll do is I'll run this code. The drive is already connected. All you have to do is run this code. Your login page will come up. You have to put your credentials, email ID, password, and that's it. You are connected to your own Google Drive. The moment you are connected to Google Drive, as you can see on my screen, I am able to run these codes. What these codes are doing? This code is going to the exact location where my CSV file is there, and by using Pandas, I am able to read this file. And I'll be able to do that for all the notebooks. As you can see, I'm running 3 different notebooks, and all the notebooks I'm able to connect to my drive and read the CSV file. Now, the first code that I ran here is data frame equal to pandas pd, which I imported here using import pandas as pd. Now, using pd, I'm using a pre-bundled function called read CSV. What this function does it reads the actual file at a designated location and saves it in a variable called df, which is of type data frame. How do you identify which is a type? All you have to do is for type and df, and it says data frame. Correct? Pandas core data frame. Now this function df.head gives me glimpse of my data. What is this data holds? It has an ID column, vendor ID, pickup date, drop off date time, passenger count, right? It has pickup latitude, longitude information, drop latitude, longitude information, store forward flag, and trip duration. Now, if you want to see the tail of the data set, that means the bottom 5 rows, then I can type df dot tail and the bottom 5 rows comes in. If you want to see some random data, then all you have to do is type df.sample and it will give you a random data point. Right? I can pass a variable here also. If I pass df.tail10, what will happen? Yes, it will give you 10 rows. So see, with such a simple amount of coding, you are already able to understand your data so well. Next, now we have understood our data. What do we have? We have these data. I can see the random sample values and all those things. Fair enough, right? Now, before I start building some charts and generate amazing stories and get some inferences, let me see what my data actually hold in terms of data types. So if I run this command df.info, what this function is doing? This function is helping me retrieve all the column names in my data set. The number of non-null values, where you actually have a value and there is no null value. And the data type, whether it's an object, that means a string or something, integer type, object again, object, integer type, right? Float means decimal numbers. And again, object means something of string nature. Now, date time is also an object type. And the flag value is also an object type. So small code, but gives us a lot of important information. Correct? What else? Now, if I run the command df.describe, it tells me about the statistical nature of my data. What is the mean value, standard deviation, minima value, maximum value, median? I hope you would have figured it out. 50th percentile is the median of the value. And the number of non-empty cells for a particular column. For example, if I look at passenger count, right? It is saying that for each row, the maximum value is 9. In one of the trip, there were 9 passengers. The minimum was 0, maybe a cancel, trip or something like that. And on an average, 1.5. That means around 2 people are there every trip. So this kind of an analysis gives it give you more confidence in your data. However, we have an explicit command to check whether there are missing values or not. So what this command is doing, this is really important. Understand its core. It is looking at the data frame name. It is checking whether is null. That means if that particular column has a particular row which is null, so the output of this function is true and false. Wherever it is true, it will do a sum. That means, for example, let's say pickup date time has 3 rows which are null. So the sum what will do? 3 rows means 3 times true will come. True means 1. False means 0. So sum of true plus true plus true, that means 1 plus 1 plus 1, 3. In that case, you would have seen here 3. But since in our data set, there are no null values, I am getting 0 as an output. But you notice one thing, right? When I did a data.info, 2 columns, namely pickup date and drop off date time, were coming as object type. But aren't they supposed to be date time format? So for that, what I'm doing is, I am converting that data column to a date time format. In this case, what will happen? I'll run this code and look at the output. My pickup date and drop date time got converted into date time 64. This is one notebook, okay, in which I'm working. And parallelly, I have opened 2 different notebooks where the original data is still in the original form only. If I do a data info here, you see these things are still object type. And similarly on the other notebook also. Right? So why I'm trying to show you different notebooks at the same time is I'm trying to tell you that the original data is still the same. This is just temporary data manipulation. This is what your feature engineering is called. I am playing with the data as I am progressing. So what is happening here is during the runtime process, I am trying to change the data type of my column, but the original column is still object. Next is I'm doing a slightly more complicated feature engineering. Why it is so little complicated? Because I realize the pickup date time and drop off date time is there, right? And then there is a column of trip duration. I want to get it into a format where I can understand like how in terms of minutes, right, it is able to fetch that information, because at the moment it seems like these are seconds, right? So maybe if I divide that by 60, I'll get a sense of data in a more understandable format. So when I run this code, what this command did is it converted that trip duration into minutes by dividing it by 60. And then adding a new column, data frame, a new column name equal to old column name divided by 60. So what this command will do, it will row by row pick the trip duration value divided by 60 and save it into a new column. Then pickup R. From the column pickup date time, I am fetching the R part. Can you think of a business use case? Why should we do that? Well, a lot of you might be thinking in the right direction. The reason we are doing this thing, because understand that if I have the entire date, it is of no use to me. But if I can pick R from that date, day of the week, month name, quarter name, then I can tell you in general, right, when more number of rides are booked. Maybe between 3 to 4 a.m., the number of rides are almost 0. But 3 to 4 p.m., the number of rides booked are maximum, right? What if Monday, the number of rides are maximum and on Friday, the number of rides are minimum? So I am fetching these information from that column. Right? Now we have done ample amount of feature engineering. Now let's take a look at how this data will look if I start plotting charts. So this is where the fun begins. So what I'm going to do now is going to run my first visualization chart. Look at this code. What did I do? I'm using PLT. What is PLT? If I go on top again, you remember Matplotlib is annotated as PLT and Seaborn as SNS and Plotly as PX. These are industry standards. I can give anything here, ABC or Gent also, but not a good practice, right? It's an industry standard of giving an alias to your package as standard. Pandas becomes PD, Matplotlib becomes PLT, Seaborn becomes SNS, and Plotly becomes PX. Now coming back to the chart. What I'm trying to do here is plt.figure. What this command does, it will allocate this area to me. That in this area, a chart will be printed of length 10 and the width of 4. What will be the chart in this area? The chart's gonna be this. Seaborn histogram plot for what column? Data frame, column name, trip duration minimum. And since it's a histogram, I need 50 bins. I mean, there is no data. Everything is between 0 to around 10 or 20, but I made it 50 bins. So if I run this code, what will happen? See, and if I make this only 5 bins, right? So it is giving you the data in a more condensed fashion. So do you realize why playing with these units is so important? Because your data could be different. Why would you be splitting it into such a fashion, right? And even the image size also, you can play it with it, keep on experimenting with different values. Look at the chart. It becomes so huge, right? 4 was better. Don't you think? So the reason I'm telling you all this thing is about how you can play with your data. Then title, this is the title, trip duration, X label and Y label. On my X axis is the minutes and on my Y label is the frequency distribution. And PLT show will print this chart on the screen. Isn't it fun, right? So let's make more complicated charts and get to understand the data better. Next, we are trying to study the duration in terms of bins, and then I added one thing here, right? It is still about trip duration only, distribution of trip, right? If I run this cell, notice one difference between the previous chart and this new chart, right? You observed something, a line is coming up here, which is not here, correct? Let me make it simpler. The amount of time it will take to generate the chart depends on a lot of factors. One, since it's an open source, so that the system that has been accounted to my ID right now could be a distant server, so it can take time. It could be your internet problem, so be patient, it will work. Now look at here. It is giving me a straight line here. What this line is doing basically, it is telling you the kernel density estimate, a trend. For this column, we don't have much data. That's why I'm getting a very sleek line. But imagine if you have a data, then you would have got a distribution line chart. Then that was a column which was continuous in nature. But in real world, you will get a column which is a categorical column. For categorical column, you cannot plot a histogram chart. So what will you do? You will use count plot. You all remember store and forward flag was a object type. Correct? On the contrary, duration was in numbers. So, to understand the categorical column, I am plotting a chart called count plot. What this chart does, it tells me that what is the distribution, what is the value of this particular column. So, there are two values in this column, yes and no. Right? So, wherever the pickup was done, whether there was a store nearby or not. Can you think of a business reason why companies like Uber or any other travel agency would like to know that? Because in that case, if more number of rides are being booked near a store, they would try to keep their hub nearby so that people can get the cabs faster. Once they make a huge purchase, they want cabs faster. So this way they can plan business accordingly. So you are not just printing charts here, you are trying to solve a major problem. Right? So in my data, most of the pickups were done where no store was there. So this business use case is not applicable for me. But that does not mean it's not a good idea. Maybe in future it could be a good idea, right? Maybe hospitals, malls, shopping complexes, cinema halls, eating place, food courts, sports area. Cab companies try to have a cluster nearby because there is a high probability. Airports, right? Bus stops, railway stations. you'll always see a cluster of cabs. If Uber, 100 Ubers will be there. Why? So that the passengers can get the cab faster. So this is how they visualize it. Right? Now, I plotted charts using Seaborn. I used Matplotlib to create the image area. Now let's see if we can make interactive charts, because you see, I'm not getting any interaction here, right? When I click here or move my mouse over here, nothing is happening. But using Plotly PX, if I go back here, Plotly, if I use Plotly, you see this thing? There's a very interesting thing. Look at here. The moment I scroll my mouse, you see something? The number of rows, exact value is 728.334K. And not only that, I'm getting a range also, while my original data is still intact. In the other notebooks, my data is still there. Original form, nothing is happening to it. But in this current notebook, after doing the feature engineering, if you look at it properly, you will realize that I am getting a interactive chart over there. Right? So this interactive chart allows me and gives me an option of making my storytelling skills better. Imagine if you are in a presentation and you are hovering over and you are able to tell what is happening, filter out data, focus on a key area. See, I can select this area and focus here. You saw that? How amazing it is. I can zoom in, pan area, box area, control and whatnot. Right? So this way I am making my data, and then one click and my original data came back. So not only I created a chart, but an interactive chart. Right? And then we can do the same for your categorical column also. Right? So see, 725.228K are no, and around 4040 are your yes. See, if you are finding it difficult to read the data, now you see, easy. And then one click, my original form is back. Now this is where your actual fun begins, isn't it? Now, the more complex data you will have, the more you will be able to play with it. Like as an assignment, when you are working on your own data, do this continuous chart and categorical chart for all the columns, and you will be fascinated by the results. Now look at here, I have a passenger count frequency, right? So passenger count 0, how many times that happened? One time. There was a cab booked one time, which might have got cancelled obviously, right? Because number of passengers are 0. Number of passengers were 1. How many times? 2 times. Number of passengers were 2, 5 frequency, passenger count. I am taking a subset of a data to make it more user friendly and able to read it. Right? So this way what I am trying to justify is how many times the cab was booked with different frequency. Right? Isn't it good? Now you are able to do that on the go. Like, literally I have nothing. I have not done any setup. I just went to Google Colab, opened, connected my Google Drive, uploaded my CSV, and I started doing this using Matplotlib, Seaborn, and Plotly. And that's it. I'm doing wonderfully. Plotting. Now using Plotly, I'm creating a line chart. How I'm doing it? I'm doing it a little bit more complex this time. Look at this function. Data frame group by. I'm saying group by the pickup hour. You remember we generated this column, column, hour of the day. When is the cab booked? 2 a.m., 2 p.m. Then I'm saying that during that hour, calculate the mean of trip duration. That during that particular hour, what is the average duration of the cabs? If I run this code, I get this analysis. Right? Hour of day 3, hour of day 5, hour of the day, and the average duration. 15 means 3 p.m. So during 3 p.m. on an average, trips were going 18 minutes. But at 3 a.m. it was 15 minutes. Then at around 6 a.m. the cabs were booked for only 11 minutes. I mean the short trips. But during this time, roughly between 1 o'clock till 6 o'clock, the cabs are booked for long distances, long time. So with such small chart, I'm able to generate such amazing insights. And that is what we always wanted it. Don't you think it like the job data analyst, business analysts do? This is why they love it. And this is something we are doing through coding. You could do the same through Excel, a little bit less interactive, but a huge potential. And since Excel, Microsoft Excel is being powered by OpenAI now, you can do wonders. Google Sheets are powered by Geminis, you can do wonders. And through Python, this is what you and I are doing right now. Correct? Wonderful. And this is not the end. Like there are a lot of things you're going to be doing today. Now, next is I'm creating a similar day of the week. Right? Now, instead of doing it at a hour level, I am doing at a day level. Right? Day 0 could be Monday, Tuesday, and our total duration I'm trying to capture here. Right? On the data wise. Now, look at this distribution. Isn't it fascinating? For Monday, let's say it starts with Sunday, and with Monday, the median time duration was 11.3 minutes. Around 25 percentile of my cabs booked were 6.7 minutes. On the upper hand, there was a cab booked for 35 minutes. Right? So this is how the data looks like. And it is so amazing. Just look at the variation, trend, charts, plotting. You can focus here. What if you want to study about the day 5? Right? You want to study about day 5 durations. What was the duration during day 5 and the frequency of that? How many people did that? So this is and this is an outlier, right? What if you want to study this outlier? On Monday, there was a duration for 32 minutes also. Max duration. Crazy enough visualization, right? And then a scatter plot. Scatter plot is a very powerful tool. It connects two variables to each other. How? Look at here. I'm trying to find a pattern between the latitude and longitude. Could be a little absurd for this use case, but this is for academic purpose, right? Imagine you are doing an analysis of engine size of a car and the mileage. Imagine you are trying to do the number of certificates a working person has and their salary. So scatter plot tells me a relationship between two columns. In my case, latitude and longitude. So these are the various combinations of it. And because I'm using Plotly, I get such an amazing interaction. And the best part is, let's say there are some outliers here and you want to study them. All I have to do is zoom on this area, keep zooming, and this is how I am studying. Oh, that's a data point at minus 73 latitude, longitude, sorry, and 40 degrees of latitude. Something like minus 73 is longitude and 40 degrees of your latitude. Could be your age versus your professional degree or something this or that. Right? So these interactive charts are there to generate a story. And then non-interactive charts are already there. Now you must be wondering, Jant, we created this chart here, Plotly, which was so helpful. Then why are you creating this chart here? See, it's about Plotly is a very heavy package. It is memory not that efficient. But on the other hand, Matplotlib and Seaborn are quite simple and small packages. So right now I'm working on my Google Colab, which is giving me a lot of free computational power. However, if you will go tomorrow and start working on a Amazon Lambda maybe or EC2 instance, over there if you have heavy packages, the cost will be more and the time duration will be more. Your throughput can be affected. So it depends on the scenario to scenario basis. If there is no need, why should I waste my resources? So for small usage with less computational power, efficient outputs, Matplotlib and Seaborn are perfectly fine. But yeah, given you have the option, the memory, money and time, then you can go for the fancy charts. Right? But before we go and talk about automatic, Sweetviz, and the LLM, there's one more amazing chart that I want to talk about. That chart is called correlation. Correlation is a statistical and mathematical concept that tells a relationship between two variables. For example, if a variable A values increases and correspondingly the variable B values also increasing, we say they have a positive correlation. If value A increases and value B decreases, we say negative correlation. If value A increases and there is no change in column B, we call zero correlation. This is a very important thing which help us in identifying and building machine learning models in terms of comparing two columns. So I'm using Plotly here to calculate the correlation and then plotting that into a visual element. So you see, I am clicking, hovering over this point 0.01, and it says that the correlation between your pickup R and pickup latitude is 0.01. There is no correlation. Okay, but drop off longitude and pickup longitude are highly correlated. Maybe numbers, because in that the same direction people are traveling. Same case for this. Right? Trip duration and trip duration minute have a 1 correlation. Why? Why they are so strongly correlated? A lot of you are thinking correct. Because trip duration minute was created using trip duration only. So it's very obvious these two columns will be highly correlated. That's why the correlation is 1. Right? So negative correlation means one is impacting in a negative way. Positive correlation means they are positively impacting. And close to 0 means there is no relationship. However, this is a memory heavy chart. A simpler chart is built using your Seaborn. Same output. But I don't have the interactiveness. You see, I'm not getting anything when I'm hovering over or clicking. Nothing is happening. I have to figure out, okay, this is passenger count and this is vendor ID. But here, all I have to do is hover over and it tells me that pickup longitude and passenger count has 0 correlation. So that's the advantage and disadvantages of different packages. Now that is about our traditional way of building amazing visualization and understanding our data. So what we did univariate analysis using Matplotlib, Seaborn, Plotly. We did bivariate analysis looking 2 columns at a time. And we did multivariate analysis by looking at a correlation of multiple columns. We did a lot of feature engineering by converting dates, minutes, hours, and all that thing. Now let's come to the world of your Sweetviz, which allows us to build the dashboard from scratch without writing a single line of, technically no single line of code. How? So I am doing a pip install Sweetviz. Now Sweetviz, if I show you here, it's an amazing package. Right? Okay, this is a Python documentation. Let's see if I have a, yeah. So there's an article in Analytics Vidhya, if you see, about Sweetviz library, which talks about how you can use this package and generate amazing state-of-the-art charts. So if you're interested, you can go there and you'll get more information on that. Right? For now, we are just going to this documentation. So it helps you build dashboards by just feeding in the data. All the things that we did here, all the codes that we have written here, they were giving us one chart at a time, right? After writing all of these codes. But look at the power of Sweetviz. I did pip install Sweetviz. I'm importing those packages, Pandas and Sweetviz. Then, since it's a different collab notebook, I have to connect to Google Drive again. So click this, run this cell, a window, pop-up window will come. Click on your email ID, give the password, and it will be connected to your Google Drive. Once done, please read your data. So my CSV file is saved in this zip folder and I'm able to read it. Doing a df.head, quickly do a df.tail again, just to see the data, okay? The data is still intact. All the things that I did here, these are local changes. But my original data is still intact. Now, in that previous notebook, there were so many codes. And look at in this notebook, I have only this code. That's it. The moment I run this code, right? Let me run this code. See, it has started analyzing my data. It is going row by row, column by column, and understanding what is categorical data, what is numerical data, and building amazing charts for us in the backend. It will take some time depending on the amount of data. So I be very thoughtful. Don't upload a notebook which is too heavy. If you upload a notebook that is way more heavy in terms of memory, this will keep on running for a while. And since we are using free version of Google Colab, it might crash. But in my case, I'm using a decent amount of file, right? Decent means if I do df dot shape, oh sorry, it's a instance, not a function. So if I do a df dot shape, only 11 columns and roughly 7,29,000 or 729,000 rows, which is not much in a data science world. So now report is ready. If you go here, look at here. This is my report. Look at the top. This entire dashboard got created here. You see this thing? Report Sweetviz.html was generated in this folder. Okay. All I have to go is go to notebook, collab files, and I will see this .html thing. Just with one line of code, I got this dashboard ready. What this dashboard is doing? This dashboard has analyzed my entire data and giving me a snapshot of the entire data summary. Look at here. When it comes to ID column, there are 729,322 values, 0 missing values, and the distinct values. Right? If I click on association, that takes me to the GitHub page of this the organization who has created this file. If I click here, it takes me to the Sweetviz documentation and the GitHub repo. If you are interested, please go and see that. But yeah, today we are looking at our data. So association is giving me that correlation chart with all the columns. ID column analysis. Then vendor ID. There are two values, vendor ID 1, vendor ID 2. Right? And if you look at here, it gives me all the summaries also on the right. Then about pickup date time. These are the various values. Then similarly, pickup date time is there, drop time is there, passenger count. Right? So there are total of 700. That's the actual count, right? And the distinct values are only 9. That means either 0 candidates are there, 1, 2, 3, 4, 5, 6, 7, 8, 9. Maximum 9 people are there in your cab and minimum 0 people. Then some information about your longitude, latitude, drop-off longitude, drop-off latitude is there. See on the right hand side, smallest value, most frequent value, largest value. I'm in the entire play area for you to figure out what is important for you. And just remember, the only line of code that we ran was this. Initialize Sweetviz, pass my data frame and show HTML. Meanwhile, my data is just like that. It is still is in original form. Nothing has happened over there. Right? And then this flag, store and forward flag, and the trip duration. Correct? Now imagine just writing one line of code and getting such a beautiful package of all the visualization can save a lot of amount of time for you. So today, if you get a data set and you know that there is going to be a meeting tomorrow and the company is going to talk about some machine learning models that you are supposed to build on it. So all you have to do is build this output, spend half an hour and 1 hour, and you will be an expert what is there in the data, and you can contribute a lot during those meetings and talking about stuff in terms of how you have developed a product and you know your data inside out. You can highlight if there are missing values. You can highlight in terms of which columns are associated, where there is scarcity, where is uniqueness, and different business aspects. Right? So sky's the limit to play around with this kinds of modifications. Because if you look at here, right, I'm getting in one shot an association, that is correlation. I'm getting the quick counts of rows, duplicates are there or not. Otherwise, you have to run codes for all of this, right? How much space and time memory it is taking, number of features, categorical columns, numerical columns, textual columns, right? And then each and every column analysis with proper visuals and counts for numerical columns, categorical columns, textual columns, date columns, count columns, even latitude and longitudes. Each and every information just got built out of the chart without doing any major exploration. Now, so far we have talked about traditional EDA, and we did that using univariate analysis using packages like Matplotlib, Seaborn and Plotly. We built bivariate, that is comparing two columns at a time. We built multivariate where we compared multi-columns at a time. We did feature engineering of extracting features in terms of date, duration and group by, creating new columns. And then after doing all of those things through coding, we did something automated profiling where we used pre-bundled packages like Sweetviz, and there are various more, by the way, in the industry. Okay, this is just one thing. There are various more. And then using Sweetviz, we created an automated chart. And now we will do something very amazing by building a LLM based model. So we are not building a LLM model. We are going to use an LLM model to generate amazing charts by writing prompts. Because we are living in the world of Gen AI and LLM. So all these traditional ways of building charts, writing codes, or even building visualization using Sweetviz and all is good. Okay, I'm not saying these are bad. People are still doing it. I'm currently doing in my organization, right? So working as a consultant in a data world, even I use this every day. Even though I'm working in a LangGraph and agentic AI framework, but still got to understand the data every day, right? Now, how can we do using all of these things through LLM? So for that, you need some amazing packages. What packages? You need something called Pandas.ai. What is this thing? Pandas.ai is an advanced package of Pandas built for LLM related works. It's an open source agent which allows you to type. You see this thing? Type something like what is the average revenue? What is the sales for next 3 months that we are expecting? If that data already exists in your CSV file, it will fetch that, not only give you that data and generate charts for you. So using pandas.ai, we will be using LLM. To use LLM, I'm using OpenAI today. So I have a OpenAI key. Using that OpenAI, I am going to be using LLM ChatGPT to build all these things. All you have to do is go to OpenAI API, log in and get your key. That's it. I'll tell you how to set it up. It's very simple. So I did pip install PandasAI, OpenAI, Pandas and NumPy. Then to work with Pandas.ai, you need some backend packages. That means these packages are required for Pandas.ai. Now in your local system, these might have already been installed, but in Collab, they don't come. So I have to install it. So I need an environment file because I'm going to save my API key. Ester is also required as a backend package for your pandas.ai. Like prerequisites. And if you want to see which package you have installed in your system, so currently if I do pip show pandas.ai, it tells me that I have pandas version 2.3.0. Why I'm running this code? Because pandas.ai is continuously evolving. So there is a high probability that when you are working on this notebook, when you will get it, you might get an error of version. That's why I'm adding this code. In case after 1 month, 2 months, if you get to see this video or you are practicing or watching this video, in case you're getting an error, just check the version. And if it is old, try to upgrade it. It will work. So as I can see, it works with GPT 3.5 and 4, Anthropic, Vertex AI, and RAG architecture. Okay. Then I'm importing all the packages, Pandas PD, Pandas.ai OpenAI to put my API key, and Pandas.ai, it calls Smart Data Frame. Okay. Then I'm using GetPass. Why GetPass? GetPass is the best way of uploading your keys so that when I share this notebook, I don't have to share my personal keys and you can use your own and we can keep that confidential. Because it's a sensitive information that you should not upload on GitHub or anywhere. So the package GetPass allows you to upload the key without anyone seeing it. I'll tell you how. Similarly, I'm connecting to Google Drive. And again, I'm not going to bore you with the same stuff again and again. I'm reading the file and doing a df.head. See, the data is in still original form. Correct? Same data, original form. All the feature engineering we did here are gone because this is a new notebook. Right? This is what I was telling you, that you can enter your key without anyone seeing it. Right? So I've already entered my key because it's a confidential data. So what I'm doing is import OpenAI. From GetPass, I'm importing the package GetPass. And then I'm saying that GetPass, enter your OpenAI key. This command will pop up a window. You have to enter your OpenAI key, which you will get it from here. And that's it, done. You don't have to do anything. Then I'm loading that OpenAI key that I've saved in a environment variable key and saving it in LLM. That's it, you're done. Now the real fun begins. That's it, you don't have to do anything. You need to import the package, call the package, pass your key, and that's it. Now, using Smart Data Frame, I'm saying that this is my data frame DF, which I imported here. And configuration is LLM. What is LLM? LLM, I'm using ChatGPT today. You can replace this with Anthropic, Gemini, Vertex AI, anything else. I'm using ChatGPT today. So I'm telling Smart Data Frame, which is being coming from your Pandas.ai, that load the data frame and use the LLM ChatGPT. That's it. Now I will give it commands and it will do the task for me just like ChatGPT. So look at here, Smart Data Frame dot chat. I'm telling it to do something, right? I'm saying summarize this data set for me and print that summary. So this will make an LLM call. It will hit my API key, use my API key, hit ChatGPT server, send the data and get this answer back. So this is the summary I got. Summary of the data set is there are 729,322 rows, total passenger count, average trip value, latitude, longitude values, and different factors. All these things we plotted it manually. I got it here, and it is giving me for vendor ID a unique values. Not enough. Let's do more. Next, I'm telling it to calculating average trip per day of the week. Okay, so I'm saying that Smart Data Frame, what are the average trip durations per day of the week? So instead of writing any code, I am texting. Now I'm chatting with my data frame. So imagine the amount of power you are holding on right now. Right? So what are the average trip durations per day of week? So it is printing response average duration. This is the response. It is saying that on an average Monday, the trip duration was 893. On Tuesday, 980, Wednesday, 975, Thursday, 1000, Friday, 990, Saturday, 913, and Sunday, 894. Not enough. Let's try something else. Let's try to print a chart. So when I run this cell, I'm saying that plot a passenger count distribution. But the output is there where it is. So if I go here, I go to exports, go to charts, and this is where my chart got generated. Look at here. LLM has generated this chart. You remember we also plotted this chart using code, But now all I have written is plot passenger count distribution, and LLM has generated a wonderful chart for me. And all that I'm able to do on my collab window without doing any extensive setup. That's it. Simple and sweet use case. Isn't it wonderful? Right? So this is how you can also set up your own collab windows to talk to your LLM and generate amazing inferences and charts. Right? And from here, sky is the limit. This is just a session to, create an awareness and awaken you all that there is a huge potential out there in terms of exploring your data. So next time, if you are going out for a meeting, for a group discussion, for a consulting role or anything, this is how you can make yourself well aware for all those situations. So in summary, we have talked about EDA roadmap in terms of traditional EDA, automated EDA, and the state-of-the-art GenAI EDA. So throughout this session, we talked about a lot of things, a lot of packages, amazing content, output. So please use that. Make yourself more well aware of how to take advantage of these tools and packages, which is so easy to do on the fly and free of cost, literally. For the LLM part, I'm using ChatGPT. You can use some open source LLMs also, correct? Like Mistral, Llama, or whatnot. But sky's the limit, isn't it? So take this as a starting point, build amazing products with it, keep on exploring and learning. And if you have any questions, thoughts, doubts, do let us know. Do reach out, put it on your comments, and we will be more than happy to entertain any questions, thoughts, doubts that you have. With that, I am Jayant Mahara. Thank you very much. And I hope this would have been an insightful session. You would have gained some content that will be helpful for you throughout your journey. Thank you very much and all the best.